Hello everybody, welcome to week 2. This week I am going to go over an article I just saw in the new astronomy magazine that just got released. Actually, it's for October 2020, but it has an article on the moon's far side unveiled, as we will learn in Astronomy 102, and not in really Astronomy 101, but in these early chapters we're kind of swapping back and forth between the two classes for material, and then later we'll split into separate videos for each class. The moon takes the same amount of time to spin on its axis one time as it does to rotate around the Earth one time. So what that does is that results in one side of the moon always facing the Earth, and then the other side always being away from the Earth. So no person until we sent space probes out had ever seen the far side of the moon. So actually, it was not the United States that did that for the first time. It was the Soviet Union, the country of Russia. In 1959, they sent a space probe called Luna 3, and it orbited the moon for the first time and took some photos. So let's just go over. We're not going to read everything in this article. It's 6 pages. It's a great read, but just want to go over a few highlights of information. Okay, now the moon, as it says, is 250,000 miles, 250,000 miles away, or if you like kilometers, which actually is what scientists use, about 400,000 kilometers. So the moon is 250,000 miles away. Okay. Anyway, people, typically think of the moon, the man in the moon, that there's a face on the moon. Apparently, in Eastern traditions, there's a thought of a jade rabbit pounding the elixir of life, conjuring medicines and mixing ingredients for rice cakes. And so anyway, a lot of people have attributed various things to the moon. Like, consider the word lunacy for crazy, or something wrong with them mentally, right? Lunacy, luna is the Latin word for moon. So lunacy, lunatic, in other words, related to the moon, kind of like the idea, right? Werewolves, you're familiar with werewolves, right? When there's a full moon, they transform. So anyway, there's this idea that the moon does things to people. Anyway, the moon circles our planet every 27.3 days. The moon phases take 29.5 days to go through, but it's true that officially the sidereal period of the moon is 27.3 days, roughly a month. Okay, that's where the month comes from. But now, while I said that the period of rotation equals the period of how long it takes it to spin on its axis, there's a that would result in, this is the way I want to say it, that would result in us truly only seeing half the moon, and that would be it. The thing is, due to the orbit of the moon being at a 5-degree angle compared to the plane of the Earth-Sun orbit, and we'll cover all this later in class. Actually, there's a little bit of a wobble to the moon. Sometimes you see a little bit more of the east side, sometimes you see a little bit more of the west side, sometimes the north side tilts towards you, sometimes the south side tilts towards you. So actually, there's a little bit of a wobble that's called lunation, or libration, libration. And so there it is right there, libration. And as a result, I believe, let's see, I think it was 59%. Let's see, I thought, well, yeah, where was it at? That we see 59% of, oh yeah, there it is. 59% of the lunar disk can be seen, rather than just 50%. So actually, due to this libration, which is a little bit of a wobble of You know, sometimes you favor one side or the other, or the top or the bottom of the other, as the moon orbits the Earth. We actually see a total of 59% of the moon from Earth. All right, so when you look at the moon, there are the more white portion is called the lunar highlands. The dark portion is called Maria, or the seas. Okay? And when you go and look at the back side of the moon, this is a artist's rendering of what the backside of the moon looks like. You notice you don't see that dark Maria. There's only a little bit of Maria there. There's a little bit of Maria there. But mostly it's just highlands and craters. So we'll talk a little bit about that. So on October 7th, 1959, the Soviet Union space probe called Luna 3 flew around the moon, took some pictures, and sent them back. And this article goes into a little bit of detail of how that was done. The Russians, the Soviet Union, stole special film that the United States used in high-altitude balloons that flew over the Soviet Union. One of them crashed, and they took the film and they put it in the space probe so that it would be safe to use in outer space, because it was it could resist radioactivity and high energy, and was water resistant, and a lot of other reasons. So anyway, they used American film in their space probe to take pictures. Okay, and they took 29 images of the moon, the far side of the moon, and sent them back on a TV carrier wave signal. All right, let me come back up here. All right, so this is actually a picture of Luna 3, kind of like a map of it. This is the actual first photo that they sent back. This is like a more modern recreation using the Lunar Reconnaissance Orbiter in the same position. But that's that original photo. And then this is the same photo with a modern spacecraft that's orbiting the moon, called the Lunar Reconnaissance Orbiter. That was launched in 2009. Okay. Now, the only 2% of the far side is covered with ancient lava deposits. Those dark gray spots, these right here, those are called Maria, and they're caused by lava. Lava from down inside the moon came up through and made flat plains. Okay, the front side of the moon, the side of the moon that faces the Earth, is covered 31% with Maria. Okay, but the far side is only 2%. Now the main reason for that is because the core of the moon, the center of the moon, is shifted closer towards the Earth due to the Earth's intense gravity. And so the lava doesn't have as far to go to get to the surface on the side of the moon that faces the Earth compared to the side that's away from the Earth, because the center is off-center towards the Earth. So the lava broke through more often when impacts or things hit the moon. It was easy for lava to pour through and fill in the cracks and smooth it off and make the Maria on the front side, whereas it was very rare on the back side, only when an extremely large collision happened. So another reason was that the Earth-facing near side broiled for millions of years under the extreme heat radiated from the infant planet. So the side of the moon that faced the Earth stayed hot longer than the backside. The backside cooled off faster, and so as a result, the terrain is different on the backside compared to the front side. Think of it like, have you ever been at a campfire when it's cold out, and the side that faces the campfire gets actually uncomfortably hot, but your backside is cold, right? Kind of like that with the moon. So that resulted in the geology, the features of the backside being completely different from the front side. All right, now both sides were equally bombarded by meteoroids, but like I said, the meteoroids hit the front side more often led to lava erupting up from down below and smoothing out and making these smooth Maria. This is a Maria, making it smooth, as compared to the backside where it took a really strong, powerful hit to do that. All right, now, this is another crater that's on the back. Actually, this is on the front side, this particular crater, down on the south side of the moon. And then, I don't want to bore you with too much information here. This is a really weird crater that's on the backside. That's named the Tsiolkovsky crater, with an interesting central landmark in the middle. So this is the crater. It has a maria. That's the smoothing of the lava. And the lava has a different color than the highlands, which is more of a white. So it's smoothed off. You can see later impact craters have made small indentions, small craters. But there's a central region there. That central peak, the crater is over 100 miles wide and has a central peak that rises over 10,000 feet above the crater floor. That's the central peak. This is a photo taken by the Apollo 15 astronauts. Okay. That's the Lunar Reconnaissance Orbiter getting a closer, more detailed look of that central. This is that central feature. This is a more recent photograph with the Lunar Reconnaissance Orbiter from July 27, 2012. Okay. The image spans 15.5 miles across. Okay. And then there is people often say that the backside of the moon is the dark side of the moon, but actually the moon, every part of the moon it takes 29.5 days for the moon to go through one complete set of phases. Exactly half of that, so 14.5 days. It's every spot on the moon, no matter where you're at, spends 14.5 days in sunlight, 14.5 days in darkness. So there is no dark side of the moon. Every part of the moon spends half of its cycle in darkness, half of it in light. So even though we think of the backside of the moon as the dark side, it really isn't. Okay, so that's what that says there. And now more, there's a crater there on the south pole of the moon, by the way, that has a mountain that got created. It's got a terraced crater that is twice as deep as Mount Everest. So Mount Everest is 27,000 feet deep, or 27,000 feet high. This crater is 55,000 feet deep. This crater here on the South Pole called the Aitken Basin. So anyway, the moon has all kinds of interesting features. High mountains, craters, smooth plains caused by the lava, maria, these deep crevices, all kinds of things. Now, January 2019, the Chinese were able to land a space probe on the backside of the moon. And it was the first object that landed on the backside of the moon. It's called the Chang'e 4. So, they've been working on the moon as well. And that is it. That is the Chang'e 4. That is a photo that space probe took of itself and then transmitted to Earth via. If you're going to land on the backside of the moon, you never can see the Earth. So you have to have some kind of satellite that you launch that orbits the moon so that you can send a signal to it so that you can contact Earth. So that's what they did there. So this photo is actually from January 3rd, 2019. And then that is the crater, the South Pole Aitken Basin, which stretches from the Aitken crater all the way to the South Pole. I guess that's the basin. Is then the moon's largest impact feature. I guess something really large hit the moon sometime in the past. There it is. All right. 60 years after Luna 3's visit in 1959. The far side is considerably less dark. Anyway, I just wanted to take some time to go over this Astronomy Magazine article on the dark side of the moon, so to speak, the far side of the moon, and just give you a little introduction to something that's hot off the presses. All right, have a great week. We'll talk to you later. Bye.